On September 12, 2025, stargazers detected an unbelievable sight. A massive entity hurtling in from the far reaches of space. Its trail extended over 5 times the diameter of a full moon, outshining any spectacle since Oumuamua. Soon after, confirmation arrived for a second intruder, each hurtling toward the sun for a near encounter just weeks apart, but originating from entirely opposite regions of the cosmos. Experts pegged the chances of this stellar duo as incredibly remote. The standard explanation? Paired comets. Yet clues suggest deliberate design. Now, an even larger enigma is invading our solar system, purpose unknown. Could this be a cosmic mishap or the opening gambit in a covert scheme we've unwittingly set off? The tale unfolds from this point. That day, the spacecraft's SWAN sensor captured an image that left experts stunned. An unfamiliar body, vivid and undeniable, surging across the solar system. Data flooded in quickly. The tail spanned almost 2.5 degrees in the sky, roughly 5 full moons wide. Such immense proportions are unprecedented for a fresh comet find. Early light measurements rated it at magnitude 7.4, visible through modest home telescopes or even binoculars. Word raced around, prompting hobbyist skywatchers to verify the satellite's detection. In Australia, merely 2 days post-alert, a spotter snapped a striking photo of the intruder. A luminous streak so vast it nearly overflowed the frame. By September 13th, the International Astronomical Union formalized it as C/2025 R2, dubbed with the SW designation to honor the spotting device. Over the following weekend, pros and enthusiasts alike zeroed in, exchanging photos and luminosity readings worldwide. The object's enormous scale and glow ignited rampant conjecture. Today's typical comet discoveries are dim specks, demanding hefty scopes for a glimpse. SW, however, shone for anyone in the know. Its appendage carved through Virgo, intensifying as it neared the sun. The first responses went beyond thrill, they bordered on incredulity. This went far beyond a routine frozen wanderer from the fringes. The figures defied modern benchmarks. As updates mounted, a pattern emerged. SWAN was asserting a commanding presence in the inner solar system, unmatched since Hale-Bopp or earlier eras. Hobbyists, quick to notice shifts in glow or quirks, were already theorizing on the forces behind such an expansive, radiant tail. For the moment, this behemoth was simply too immense, too striking, and too swift to dismiss. As global observatories followed its trajectory, focus pivoted from its identity to the timing of its entry. And if that coincidence hinted at a deeper, odder enigma, C/2025 R2, formerly christened SWAN, isn't the sole fresh arrival captivating eyes this October. Mere days prior to its reveal, 3I/Atlas was already en route, slicing in from a wholly distinct sky zone. SWAN's trajectory hails from Aquarius, whereas Atlas approached via Sagittarius. On celestial charts, their entry paths diverge by over a quarter of the sky's expanse. Still, both are slated to hit perihelion in the same 10-day span. SWAN's peak nears on October 20th at around 150 million kilometers from the sun. Atlas precedes it by 3 days on October 17th, grazing the sun at about 203 million kilometers. This positions their solar closest approaches a mere 50 million kilometers apart, tighter than Mars' nearest to Earth. It's more than mere date overlap. The layout is remarkable. Each follows a sharply angled orbit, with SWAN deviating over 60 degrees from the ecliptic and Atlas almost at right angles to the planetary plane. Their incoming directions vary so wildly that random chance alone makes simultaneous inter-system crossings at comparable sun distances extraordinarily unlikely. Those monitoring extended orbit comets and extrasolar visitors expect erratic timings, with solar grazes scattered over months or years. But now, the decade's 2 most luminous newcomers are aligning toward the sun in eerie tandem, each from sky's opposing flanks. The schedule deepens the intrigue. As SWAN and Atlas make their solar sweeps, Earth's scopes face obstruction. From October 8th to 18th, solar brilliance hampers straight viewing, forging a blind spot over the key period when anomalies might shine clearest. Thus, Their nearest solar and mutual brushes occur tantalizingly beyond grasp. Ground-based watchers had no chance to monitor the action as it happened live. Bringing two entities from such distant starting points to reach their closest solar approach mere days apart, at almost identical distances from the Sun, right when the star itself blocked any direct sight. That setup bucks the normal odds of pure luck. In orbital mechanics terms, we're talking about a pathway, a tight slot in space and time where both share the same slot. Coincidence, some concealed connection, or deliberate design? That's still up for debate, but the sheer alignment is compelling enough to give pause to the doubtest stargazers. 3/Atlas grabbed headlines not because of its shine, but for how it shattered norms. Initial readings from the Atlas spectral analysis crew flagged something alarming. A composition heavy on nickel, but almost devoid of iron. That clashes with standard comet profiles, where iron-nickel combos typically dominate the gases. The revelation was so outlandish that several teams demanded a double-check on the raw info. What followed was a flap over instrument tuning that leaked into online astro discussions and sparked a flurry of outside audits. Tensions ramped up with fresh scans. Rather than the usual water vapor dominance, 3/2/Atlases surrounding haze spewed carbon dioxide at levels five-fold those of water. The 4.3 micron CO2 signal overwhelmed the readings, with H2O scarcely poking through the background fuzz. Unusual, sure, but not unprecedented for icy bodies from frigid zones. Trickier to dismiss were the oddities in the tail's movement. Trackers following Atlas's path spotted a rhythm. 3 separate speed boosts, roughly 2 weeks between each, lining up with abrupt shifts in the tail's hue. The initial surge hit on July 29th, the follow-up on August 14th. Imaging records captured a spike in luminosity, alongside a spectral tilt from ruddy tones to almost flat, then reversing. These delta-V bursts didn't mimic the steady nudge of solar warmth. They hit hard and quick, then ebbed like a burst from an engine. Critics in the review process countered with worries over sensor drift or overlooked biases. Yet the Atlas Spectral Group stood firm, noting how the burst schedules and strengths aligned from separate sites, spanning the Abro monitoring grid to Bill Gay's scattered scope setup. The figures didn't align with ordinary gas releases. The tail's CO2 balance appeared to fluctuate right alongside each boost, an effect dubbed propulsion blend shifting by some observers. The real buzzkiller for doubters came from the power calculations. Assuming those velocity changes were legit, the onboard energy supply in Atlas would have to churn out around 10 gigawatts, equivalent to 10 big atomic reactors. Way more than any comet core could naturally produce. Consensus science insists natural forces explain most observations, but the holes, particularly the nickel-heavy readings and the staggered velocity jumps, keep the artificial craft theory simmering. For the moment, the Atlas puzzle stays unresolved, with every batch of new info stoking both doubt and wild guesses. C/2025 R2, better known these days as Swan, carves its own niche. The stats paint a vivid picture. A tail spanning 2.5 degrees, a luminosity crest matching the century's top comets, and a nucleus that, per the boldest projections, might unleash 10,000 gigawatts of power. That's surpassing Earth's total electrical network by a wide margin. Yet scale alone isn't what's stirring debate. It's the bold assertions from astronomy's outer edges, suggestions that Swan boasts protective layers, defensive barriers, and drive systems pushing beyond established physics. The murmurs began with reflection profiles. Normal comet hearts diffuse sunlight in expected patterns, but Swan's center bounces it back with a crisp metallic echo. Hobby spectrum experts claim this echoes not only nickel, but a nickel-cobalt alloy, the sort humans pick for durability and rust-proofing. Phrases like nickel-cobalt shell started popping up in forums and overnight broadcasts, boosted by how the thing resisted crumbling or fading near the sun. Next surfaced tales of a visual quirk, a steady silver glow encircling the core, varying in shape and glow. For believers, it resembles an ionized sheath, an energy field repelling solar particles and space junk. Hence the Fortress label, where 3/2/Atlas feels like a nimble scout, swift, maneuverable, strangely optimized. Swan comes off as a juggernaut. Deliberate, unyielding, apparently bulletproof. Its already epic tail shows faint, periodic nudges that upend basic gas ejection theories. Imagery breakdowns reveal subtle, repeating swings in tail trajectory, as though the body is tweaking its flight path. With accurate bursts of plasma energy, every surge shows up as a spike on the light intensity graph, and the sequence recurs with a consistency that's tough to dismiss as mere random flares from the surface. The trajectory details pile on more intrigue. Swan follows an orbit that circles the Sun every 22,554 years. Such an extended loop overlaps with the end of the most recent ice age. The conclusion is mind-blowing. Should this body be artificial, it has followed a programmed route for a duration exceeding the span of human society. Remarkably, it shows up right now, alongside Atlas in the identical solar path, precisely when solar glare hides Earth-based observatories. The probability of these elements aligning accidentally is extraordinarily low. All these clues build a mounting conviction that Swan transcends a typical comet. Its intense glow, suggestions of sophisticated protection, potential reinforced exterior, and the magnitude of its power generation position it as the most imposing visitor to the inner solar system in recent history. Be it a stronghold, an explorer craft, or an entirely different entity, Swan compels skywatchers to overhaul their assumptions and invites concepts once confined to speculative tales. Each key irregularity noted for Swan and 3i/Atlas shifts the discussion from their nature to their potential purposes. When two enormous entities, one with a 22,554-year recurrence, the other tracing a hyperbolic, potentially extrasolar trajectory, converge so closely, the chance of coincidence plummets dramatically. The synchronization, the spatial setup, and the observational blackout have sparked numerous ideas about expeditions. One concept seems almost ordinary on a cosmic scale, a planned service or replenishment operation. Here, the Sun serves as a service station. These items might be designed to harness solar radiation or magnetic forces for power restoration, information transfer, or equipment checks. The notion aligns well with strategies for far-flung voyages. On the planet side, we routinely employ solar passes for gravity slingshots and power gains. For scout vessels, the Sun makes perfect sense as a spot to recharge or relay updates. A darker hypothesis emerges next. The proximity might signal an operation, a meeting to retrieve or disable a faulty component, or even a clash among competing groups eyeing a vital asset. Projections of their energy capacities, Atlas around 10 gigawatts, Swan at an immense 10,000, indicate the reserves required for deliberate navigation beyond mere coasting. Gradual speed increases and tail adjustments in Atlas, along with tiny propulsion jets in Swan, suggest a degree of guidance consistent with operational objectives, rather than erratic venting. Consider, too, the progression of inspections. Oumuamua in 2017, then Atlas, and presently Swan, might form a series of intensifying reactions to humanity's decades of radio signals. Successive visitors could embody increasingly intricate devices dispatched to survey, collect intel, or advance engagement. Across these models, the Sun plays no passive role. It functions as the energy hub, the gathering site, the signal. The data doesn't resolve the arguments, yet it prompts a fresh inquiry. If an operation is underway, what drives it? A 22,554-year path exceeds a mere orbital figure. It spans back to the depths of the prior glacial period, when the planet bore little resemblance to its current form. Circa 20,000 BCE, ice sheets blanketed vast swaths of the northern regions, and weather patterns evolved in manners that influenced the dawn of human societies. That era imprinted itself in polar ice samples from Greenland and Antarctica, revealing strata of particles and subtle isotopic shifts that allude to abrupt celestial spectacles. Certain scholars note alignments between these strata and eras when luminous, extended orbit comets might have traversed nearby, depositing not only fragments, but narratives potentially passed through oral traditions. Central to this notion stands a location named Göbekli Tepe, a settlement in southern Turkey erected over 11,000 years past. Its rock formations feature engravings of beasts and symbolic designs, including patterns that enthusiasts interpret as celestial tracks, perhaps tracing cometary arcs. A few proponents claim these inscriptions document rhythms spanning beyond mortal spans, possibly noting the recurrence of an entity akin to Swan. Orthodox perspectives remain far more reserved. Experts in antiquity and celestial studies caution that such links are conjectural, resting on alignments equally attributable to luck. The contention rages, with detractors emphasizing the absence of concrete proof linking these prehistoric structures to precise stellar rhythms. Nonetheless, the alignment resists dismissal. Should Swan indeed loop every 22,554 years, its prior incursion into the inner solar system would coincide with the planet's thaw from icy dominance, at a juncture when early peoples began erecting landmarks and observing the cosmos. If mere happenstance or deeper significance, that remains an open puzzle. This open-ended puzzle lends an even deeper mythical aura to what was already a remarkable occurrence. Ultimately, the tale of Swan transcends mere metrics or trajectories. It's a reminder that the heaven's most elusive guests may have long been intertwined with the origins of our world. From October 8th through 18th, every prominent Earth-based observatory encounters a strict halt. Public timetables label the period as downtime due to solar conjunction, yet the limitations extend much deeper. Confidential directives from U.S. Space Command and the European Space Agency instruct personnel to halt all radar operations and detailed imaging of Swan and 3Y/Atlas throughout this blackout. Certain ideas for substitute monitoring get rejected sans rationale. Demands for unprocessed data are subtly diverted or postponed. A few allocation overseers for telescopes, chatting anonymously, mention clear mandates to steer clear of any public comments on the objects prior to perihelion. Consequently, an imposed hush falls right when these two rarest interlopers in years traverse the sun's blinding light, forcing reliance on a slim cadre of freelance stargazers and hobbyist collectives to bridge the void. As the blackout directives landed, formal outlets fell quiet, but enthusiast circles buzzed with activity. Bill Gray, a seasoned analyst famed for his freely shared trajectory computations, mobilized a loose alliance of home-based skywatchers and modest facilities. His appeal spread via online boards and secure messaging groups. Train your instruments upward, record each glint, and disseminate the unfiltered observations swiftly. The Ibero Tracker Collective across Spain and Portugal started merging Broadview detector streams, while whispers from exclusive stargazing clubs hinted at improvised strategies to skirt the restrictions via radio arrays and even converted meteorological orbiters. With official bodies staying mum and major installations sealed off, this volunteer push emerged as the sole bulwark against complete data drought. Anybody equipped with a scope, antenna setup, or freely available monitoring tools could pitch in. Far from mere obstacle, the blackout span turned into a summons. Craving clarity? You're now on the hunt. Upon Swan and Atlas resurfacing, initial detections could hail from a suburban patio rather than a state facility. The evidence stands firm. A pair of irregular bodies invaded the solar system's core in tandem, bucking probability and prompting queries that no organization has resolved.